This is a presentation about quality systems in manufacturing. I'm going to explain why it's not called quality control anymore. Just a quick history of things about quality. Most people say that in this country we started looking at it from George Washington's day. He expressed a need to standardize weights and measures in this new country, because the weight of a pound of gunpowder was different in one state than the weight of a pound of gunpowder in another, and it really was very difficult to do business when something like a keg of gunpowder was called the same thing, but it wasn't. It took 100 years for the U.S. to establish the U.S. Coast Survey's Offices of Weights and Measures. That group later became the National Institute of Science and Technology, as it's known by today. But the Coast Survey's Office of Weights and Measures did start establishing some federal standards, but it was getting kind of late. About a decade prior to that, the railroad companies were looking for some regulation. One railroad company would build their railroad cars with soft metal wheels and soft metal rails, and another railroad company would build with hard metal rails and hard metal wheels. And when the box cars with the soft wheels got onto the railroads with the hard rails, they would gum up the rails, and it would be a problem. And also, when the hard wheels got onto the soft rail types, you would end up with they'd tear them up. And so the industry needed regulation, but the government wouldn't do it. So they had to self-regulate by establishing the American National Standards Institute, that basically told the railroad companies to use this kind of metal on all your wheels, use this kind of metal on all your rails. So when you hear people say government regulation is bad, it really isn't. This could have been solved, and it's solved in most countries, by having national standards organizations that are actually run by the governments. Okay, a little more on history. These are events that really bring into play the ideas of quality and or the lack thereof. World War One. At the end of World War I was the Spanish flu pandemic, similar to what's going on these days. Cities were quarantined, and the flu that came from that particular virus was just as bad as the one that we're getting with this coronavirus. And there's always a lot of trying to cut corners during those kind of events. During the Depression, by the way, in between the flu pandemic and the Great Depression were what were called the Roaring Twenties, a very big time for economic expanse. So look for good economic times 2 or 3 years from now. But going back, in World War II, people were trying to make sure that they were building quality aircraft and materials, and the military established military specifications, and it was through the sheer ability for the U.S. to mobilize and create great military that we won World War II. In 1947, the International Standards Organization was founded in Europe because Europe had been devastated and they needed to rebuild. And every country in Europe had its own standards, its own railroad gauge, and its distance of the rails apart, so you couldn't carry goods from one country to another on the same railroad car, so they had to be unloaded at each border. So at the end of World War II was a good time for them to standardize everything so that they could do some trade and some business across country borders, and the power grids could be compatible. Lots of things that they standardized using ISO as a way to do that. And one of the other big events for quality was 1984 when a Motorola executive gave a famous Six Sigma speech. More about that later. Like I mentioned, in the wars, it's trying to build better equipment, better guns. The gun cartridges developed in the Civil War. That means the guns became more standardized, easier to build. The World War II, trying to build a ship a day, led to a need for quality control and the things called military specifications. Competition is another thing that happens. In the 1950s, when the Russians launched a satellite called Sputnik, it scared the bejeebers out of everybody in the U.S. And so we built our space program. In the 1970s, Japan was becoming one of the world's biggest manufacturing centers. And we decided we would try to build as good a vehicle as they could. Today we're seeing it with China and the competition in manufacturing. So competition or feeling that you need to do better than another country will improve cause a country to improve their quality standards. Now, I keep using this word quality, and it's not the shiniest, it's not the one with the gold trim. It is a quality part is one that meets the customer specifications. Or that standard. And so a quality system is one that applies process standards to make consistent parts. The old saying is, you say what you do and you do what you say. You say what you do by the drawings, by the documents that are part of how you're going to build and manufacture an item. And then when you build and manufacture an item, did you do it to the specifications of the drawing and other documents? And then you measure the outcome. Measure how many did we get right, how many did we get wrong. And I mentioned that the word quality control is not in particular use these days. That's because people often end up emphasizing the control, and that sometimes backfires. And a little bit more about that when I get into talk about how quality used to be done. So let's look at that definition of quality: providing a customer what they want. You may not realize it, but every time you buy something, you are entering into a sales contract. You buy that hamburger at McDonald's, you are giving them your money, and they're giving you a piece of food with the expectation that it's not going to make you sick, that it's going to have a certain level of taste, and that it will be satisfying for that amount of money. Now, of course, commercially, there's a lot bigger stuff in contracts written out. If any of you have ever bought a new car, you know that there's about 4-inch stack of papers that are part of that contract. Okay, so there's going to be that transaction in that contract. The customer gets to be a little tricky too. If you buy a Black & Decker drill from Lowe's, are you the customer of Black & Decker? Or are you the customer of Lowe's? Who is Black & Decker's customer? Well, Black & Decker customer is the hardware stores, where they sell their stuff to the hardware stores. So that's their customer, not the individuals who buy them at the hardware stores. So it gets a little bit tricky. Black & Decker wants to keep the hardware stores happy. They're not worrying about the end user. So keep this in mind as you study this in some of the industrial technology management courses, that developing that supply chain, which you're hearing a lot about these days, it's a really big deal. And that's where the customer is really pretty critical. And giving what they want, and that's the specifications that the customer provided or didn't. If they didn't, then you're kind of shooting at the dark. But if you're building something for a group of people, you want to hear exactly what they want. Now, you have to create a process to build your widget. That's what you guys have been, why I stressed doing that plan. It's writing those work instructions that develop that process to build the widgets. And you can develop a great process for building a great widget, but are you building the widget the customer wants? Becomes a interesting method. And I'll save that for the quality courses you'll be taking. Well, back in the day, like the 1960s, 1970s, the idea was that you build your part, however many processes it takes, then you check it. If it's wrong, you rework it, and then you ship it. Well, we're going to see that manufacturing is not done the way it was back in the right after World War II. If you were building cars, start over on the right and go up, and you build a car and you do a process to it, and the assembly line goes along the way, and then it goes along, and you get to the very end at the left. And what would happen back in the 70s is the quality control people would pull a car off the assembly line at the end, take it to a special place, inspect it, look at what was right or wrong about it, and they might say, oh gosh, the passenger door is not hung properly. So it would send it back to the passenger door place and get it back on the line right there. Those people would be written up as having had a failure, and they would hang the door properly. Well, if there was something wrong with the door hanging system, they probably shipped 100 cars before they got back to the point where there was obviously some tooling was wrong in the equipment that they used to hang the doors. And so that sending that one part that came off the line and was not back for rework was just not a very good way to do it. What it's done today, though, is that, and this came in from something in Toyota, lots of places along the line are checked. You checked, is the door hung right? Is the seat installed right? Is the windshield in right? Is the engine put in right? And you make sure that all of those, everything is done correctly along the way. There's no need to take the last car as it comes off the line and check it anymore. And this created a huge difference in the way companies functioned. They had it used to be that the quality control people, that's what they would call themselves in the old system, were not much liked by the people on the factory floor. All they did was go around and give them bad news, write them up, do something that would maybe impact their paycheck. You didn't hang this door right. It's going in your file. And so, in fact, when the auto companies would have their annual company picnic, and all the people from all the company would be there. There were two groups that were not invited to attend the company picnic, and that was the quality control staff and the security staff. Because they were all, the security people were all part of the, or employees of the company. Nowadays, the people that check you at the front gate are probably an independent contractor, but at the time they would be company employees, and they didn't want the company employees to get too friendly with the guards, and they didn't invite the quality control people because they knew fights would break out because people didn't like the quality control people. And it's no surprise that the late 1960s were the worst. The automobiles made in the 1960s were the worst quality vehicles made in the U.S. Okay, they're kind of considered, they're 5 quality system movements, and a company sort of picks and chooses, maybe uses 1, maybe uses 2, maybe uses 3. But the total quality management or quality management systems kind of go together. And then there's Six Sigma, which brought up before, Lean, which is the Toyota production system, Malcolm Baldr's Award, and ISO 9000. Now, the total quality management is your kind of theoretical textbook quality system. And if you remember, it's based about saying what you do with your drawings and documents, and then building according to those drawings and documents, and comparing to make sure you actually did build to those systems. And it's really gets into the control of things more than the quality. I'm going to give you an example of a couple of these to give you an idea of what they do. I'm going to look at the project methodology. Edmund Demings was a engineer at the Hawthorne General Electric plant, and after World War II, he ended up going to Japan to help the Japanese rebuild, and he brought with him a whole lot of ideas about quality. And he'd established a cycle to improve things within a factory. And it's called the Plan, Do, Check, Act cycle. And it's pretty straightforward. You plan out what you're going to do to solve a problem. You do it. You check to see if it actually worked. And if it did, you either incorporate it or you come up with a new plan and keep working on it from that. Fairly simple, and people still do use this a bit, and it's a good way to get some things done. Now, one of the stuff that you'll find in all these textbooks, the quality management system, is that the management system, quality system, has to have in the case of the textbooks, it's going to have 6 things: customer focus, process approach, leadership of people, an improvement scheme, and that decision making is done by evidence, not just by gut reaction, and that the stakeholders are going to have some sort of input into it. Now, what's a stakeholder? It's not a shareholder. A shareholder owns stock in the company. They are stakeholders. It's not the employees. They are stakeholders, and so they would have some input. But it's also the user, whoever uses that equipment. And so if, who's a stakeholder in McDonald's? Well, the people who make beef, the people who make bread, the employees at McDonald's, the people who eat at McDonald's, the heart surgeons, because eating too much at McDonald's ends up causing people to have heart attacks. So if you're a doctor and want to do a lot of heart surgery, you want people to eat a lot at McDonald's. Okay, that's stretching a little bit, but you get the idea that it's not just the employees and the financially bound people, but the users of their equipment. So that's number 1, total quality management or QMS system. Number 2 is Six Sigma. And that speech that I referenced back in 1984, the guy essentially said that Motorola was going to hold to control limits of 6 Sigma. Now, I remember when I was working in an industry doing a lot of statistics, and when that came out, we all kind of laughed. I said, that's not possible. By the way, if you think Motorola's just made some TVs in the distant past, they make a lot of the electronic components that go into things like cell phones and all kinds of stuff. They all the basically all electronic components, resistors and chips, except for the Intel chips, are Motorola chips. And they must be designed by Motorola, maybe made by other companies. Anyway, they said they were going to do Six Sigma. That everything would be within that range. And just to refresh your memory, 1 Sigma variation is about 34.5% either side of the median amount. And then that exact same distance on that graph goes out and it'd be another 13.5%. So you're looking at 95% being plus or minus 2 Sigma. Plus or minus 3 Sigma is even smaller, and plus or minus 6 Sigma is outrageous. Most control limits are set between 1 and 2 Sigma. And to go 6 is like, oh man, that's the dumbest thing in the world. Well, you can meet those limits if you change your standards, which they kind of did to make it look like they were doing it, but it's a lot more involved with the Six Sigma approach. What they came out with is that they were going to use mathematics and statistics to control their quality. And that's the way you got to do it. You don't just have gut feelings if you're leaders. That's dumb. They also established these certificates for individuals who had gone through their training. The way they set up their training was a thing called Motorola University, and they did it for all of their executives and top engineers, and they taught them about the quality, and then they eventually opened it up to people in other industries. And it was kind of a virtual, it was not really a campus anywhere, but these people would do things and run these exercises, learn the statistical way of controlling quality. And if they saved their company so much money in their processes, they earned a green belt, did a second one and earned even more. They get a black belt. And it was a way of getting people sort of, and those are still very big. If somebody's in charge of a quality system at their company, they'll probably have some sort of Six Sigma certificate. Now, to be able to explain this again, I'm going to go through the project methodology for Six Sigma, which is a little different than the Plan, Do, Check Act. And that is that you define the problem first. You know that there's a bottleneck somewhere. What is the where is the real bottleneck? Once you've defined it, you make measurements all around it. How many steps do people take to move parts from one bench to another? How many, what's the lighting like? All kinds of measurements. Then you analyze all that data. I mentioned this is all about data. Then you put in methods to improve it. And here there's kind of a problem. You got to make sure that they actually work. And if they don't, you stay in that improve cycle and spot until you get it proven that it works. And then you control it. And you make sure that this is the way you build these things, not don't take these shortcuts. They don't help. Or here's some shortcuts that will make things quicker. And this goes back again to why I have you write your plans, because you're writing out work instructions, which is exactly what this kind of process methodology comes up with. Okay, the third type was called Lean, and it came out of the work from Edmund Demings working with Toyota and other Japanese manufacturers, and I'm just going to give you a couple of things of Lean. You'll see them in other classes, and this is simply an introduction to quality systems, which, by the way, we had to put in here. We have always had it in here, but it's part of our accreditation that you get an introduction to quality systems here. Well, Lean processes says they want to reduce waste, and they identified 7 types of waste. You can read them, and you think, why is reducing inventory waste? Well, let me give you an example there. Let's say you got printers that within your office. You go out and you buy 50, you get 3 printers, and so purchasing guy goes, I got a great deal. I can get 100 ink cartridges, and I'll put those on the shelf, but whenever they need it, they'll be there ready to go. Well, those printers last about 6 months, and you got to throw them out, and it's a new cartridge. Then you end up having to throw away a whole bunch of cartridges because now there are no more printers that use those. So you want to have in stock just what you think you're going to need for that particular time. And that is one of the things that does, is it kind of gets into just-in-time manufacturing, which means that you take delivery of the subcomponents just as you need them, not stocking lots of them. It's a way of reducing waste, and the same thing with others. Lean also stresses the 5 S's, and these are the English versions. They also have a Japanese version that is an S. Sort, straighten, shine, standardize, sustain. And you can imagine how, working on a lathe, you want to sort things out, you want to keep everything straight, polish it up every now and then, clean it off, standardize things, and sustain it. And a lot of companies add safety and security, make it 7 S's. And these are things that you'll find in a plant. There'll be a monthly emphasis, and it'll be, we're shining things up this month. And so everybody's expected to keep a rag with them to polish their equipment. Fourth way that a company can try to achieve a quality system is to follow the Malcolm Baldrige Award criteria. And Malcolm Baldrige Award is sponsored by National Institute of Science and Technology, and it's similar to what's called the Deming Prize in Japan. And the Deming Prize really made companies want to win that, and it brought in that competition. The Deming Prize was put up by the Japanese government for the best manufacturing company in Japan, and they fought to try to win that every year. So NIST decided to copy that, and they give awards to companies in production or manufacturing, and organizations in education, and organizations in healthcare. And their criteria are 7 here. Leadership, strategic planning. You can read these, but you'll see that they are very similar to the ones out of the textbook. Here, big emphasis on measurement analysis and knowledge management. The last one of these is ISO 9000. ISO is an organization centered in Europe, in Switzerland actually, is where their headquarters are. And if somebody says that they know that the name is the International Standards Organization, well, no, that's not really what it is. And if you look at it in French, it would be the Organisation d'Internationale de Normalisation. No, wait a minute, that's nobody really knows, but they think that the name really comes from Greek, meaning equal, and so it's not an abbreviation at all. It's just what it's called. But for practical purposes, call it the International Standards Organization. And it's right after World War II, and there are 162 countries are members of it, and most countries are represented by a government body that does quality standards. The U.S. is represented on this at ISO by the American National Standards Institute, which is a private organization that does standards. So it makes it really kind of unique and different. Their 9000 series standards are about quality. They have thousands and thousands of standards. They say, here's the kind of material that goes into a light socket. Here's the kind of material that has to be in an electrical outlet. Here's the width of the plugs of an electrical outlet. But they also have a series for quality. What they did is they made multiple segments, and it's about the process. It's not about the product. It's about the process. Or say what you do and do what you say. Is that process right? Is that being done for every component? Is that being done in purchasing? Is that being done in record keeping? Is that being done in the machining process? Is that being done in the transportation from the warehouse to the factory floor? All of those things are in there, and it's a way that you can find out all of this within these clauses. But there's also then a part of this where an outside auditor comes in and looks and sees if you're doing it right. Is everything like it should be? Is it going to fit? And so it's a certificate program. Companies get a certificate saying that they've got this, they meet this standard of quality. And that way when people buy their product, they know that it's a quality product. Now, it's not really for consumer level. You don't see it for people on the consumer level, but Dell, for example, wants to buy all of their components from ISO 9000 certified companies because they know all the subcomponents will be made correctly, but Dell itself doesn't bother going through it because the regular consumer doesn't know what ISO 9000 is. Another big trend these days, besides quality in manufacturing, is the environmental movement. ISO has a set of environmental standards that kind of come close to making a company green, if you will. And there's a lot of things happening in a lot of factories. The Ford Motor Company took one of their factories and put grass on the ceiling and ended up reducing air conditioning cost. Grundfos here in town operates in the summer from 5 a.m. to 2 p.m. So that they won't run the air conditioning very much. They put out a lot of solar panels. One of the things that ISO did is they established the RoHS requirements, and that meant that they would not allow products with lead, mercury, cadmium, all these other bad chemicals in it. And so companies have had to change how they do things. If you look at the wave soldering system that was put out on the single process videos, I think there was a reference in there to the how they wave soldering had to change and use tin instead of lead because they wouldn't allow lead to be shipped into Europe in the form of circuit boards. Okay, that's the thing about quality. This is just an introduction. We have entire classes on it. But like I said, for our accreditation purposes, you are expected to be exposed to it a little bit in this class.